Today I will show you a few use cases of rePOWDER capabilities. Take a look at the periodic table. The red elements are those that we processed or our customers processed using rePOWDER. Of course, you can see there are a few strange elements to be atomized, like oxygen. Those were oxides, or those were parts of metal matrix composite created with rePOWDER. The red elements, including very reactive ones like lithium, and also refractory like tungsten or rhenium, were atomized using rePOWDER system. Either induction or plasma capability brings us very large scope of materials that we can process there. Let's start with a few examples on the induction part. Talking about reactive materials, there are very few more reactive materials than magnesium-lithium, an alloy with density close to the density of water, consisting of both extremely reactive materials, was atomized successfully using induction-based rePOWDER. Powder of ultimate sphericity and no pyrophoric properties was atomized and further on processed via spark plasma sintering and laser powder bed fusion. You can refer to one of our papers you can see at the bottom part of the slide. Another example of induction-based process. Aluminum with rare earth elements. In here, we employed both capabilities of plasma and induction melting. First, master alloy was created via arc melting. So aluminum, rare earth elements and zirconium was homogenized into the master alloy. Later on, it was introduced into the crucible in induction and diluted with pure aluminum. Such an alloy was atomized successfully, and you can see it in one of our papers that we published with our US partners. Multiple other aluminum alloys were processed, including aluminum with rare earth elements, zirconium, scandium, but also aluminum metal matrix composites. You will see it in the later part of the presentation. Now a few examples on the plasma part. Recently, a lot of attention was brought by C103 niobium alloys. Niobium, hafnium and zirconium system is one of the best alloys for additive manufacturing with ultra-high temperature properties. Such an alloy was also successfully processed by rePOWDER. Talking about refractories, we can also show you an example of rhenium. Precious and the second highest melting point of all of the metallic elements. It was actually pretty easy to be atomized with rePOWDER. For those, we designed a special sonot rod that consisted of tungsten and rhenium to last with those extreme conditions of over 3000 degrees Celsius melting point of rhenium. Recently we've shown new capabilities with powder to powder. There, we can also create novel alloys, starting with blends of different powders. You can see on the left part of the slide blend of molybdenum and titanium powder. Processing such powder in LPBF would provide a lot of inhomogeneities. Unmelted molybdenum, different intermetallic phases. That is a very typical case if you're dealing with in situ alloying in LPBF. Such a blend was directly processed by rePOWDER equipped with powder-to-powder module, providing homogeneous titanium molybdenum alloy at the end. Creating novel titanium, especially better titanium alloys for biomedical use, is particularly easy with this kind of system. This powder reatomization capability can be used also for recycling. We can start with material of certain chemical composition and low quality powder such as milled, HDR or gas atomized material. We use it as a feedstock and introducing it directly into the powder-to-powder module, and the feedstock, as you can see on the left, is turned into high-quality powder with no satellites that is typical for ultrasonic atomization. That is the only direct reatomization method that is capable of working with powder. Unlike spheroidization, we are not only changing the particle shape, but we can also change the particle size distribution. So no matter what the initial PSD is. Afterwards, we are getting particle size that is typical for ultrasonic atomization. If we are having wire, that is the best case scenario. Wire is the easiest form for continuous ultrasonic atomization. In this case, with our partners from Ukraine, we created a novel alloy, but without precasting, drawing, and heat treatment. We used so-called powder cord wire to create a novel high-entropy alloy. Take a look at the picture. You can observe SEM image cross-section of the wire. There is a shell of iron, and inside they are stuffed of different elements, blends of several powders, and afterwards it is all molten and creates homogeneous powder. High entropy alloys are one of the most interesting novel class of materials. Right now there are plenty of papers published on new high entropy alloys designed for additive processing. And we are also processing plenty of those with rePOWDER. In this example, a novel refractory high entropy alloy that consists of tungsten, titanium, niobium, hafnium, and molybdenum was processed. Initially, we used this arc melting capability of rePOWDER to create ourselves a feedstock. We placed those several different elements in the copper boat, remelted those using cold crucible capability, and it was used afterwards as a feedstock for atomization further on. Induction module is also perfect for low melting point materials, particularly solders and brazing alloys. It is a perfect technical industrial solution to create ourselves solders of tin or lead, or create new braze alloys for advanced applications. In here, you can see an example where we atomize bismuthium and tin, also for nuclear application. Ultrasonic atomization compared to gas atomization is much smaller. We are capable of containing the process in chamber that is order of magnitude smaller compared to gas atomizer. That's why it's perfect fit for precious alloys. If we are dealing with material worth several hundred kg, if we're processing material worth several $1,000s per kilogram or more, such as platinum, rhenium, iridium, or gold, rePOWDER and its ultrasonic atomization capability are perfect. Materials based on gold, silver, we process typically with induction module that we created with Blue Power, our German partner. Refractory, platinum-based materials, iridium, are typically processed with plasma-based system. There, we have several of those devices sold worldwide for production of platinum and platinum-based alloys. Not only the homogeneous melt can be atomized. There are several examples where MMCs, metal matrix composites, can be atomized using rePOWDER. Ultimately, we are getting a particle with a matrix that consists of metallic alloy, and inside it's stuffed with ceramic particles. We have examples both for induction and plasma version. Induction, for example, aluminum silicon carbide system. You can observe that the particle itself is a composite. It is much easier to process such a particle. It's much easier to process such a powder with homogeneous melting in LPBF than just a blend of powders, where lack of fusion is a great issue. The other powder that we processed there was Ti-TiC with titanium carbide. There, refractory MMC superior to bulk alloy of Ti-TiC was created. Ceramics or semiconductors with stable melt form can be also atomized. Our customer from US, Oak Ridge National Laboratory, shown silicon and silicon germanium alloys processed with rePOWDER. There, not an alloy of metallic elements, but pure silicon or silicon doped with other semiconductors was processed into certain particles that you can see in the slide. Funny part you can observe is that those are not spherical, but that is not due to the characteristics of the process, but crystallization behavior of the powder. We have processed so far several hundred different compositions. metallic alloys, refractory and low melting point, MMCs, non-metallic elements such as silicon and germanium. There are plenty of examples how rePOWDER can be used to progress with research of novel alloys and powder metallurgy. You can refer to our book of powders. There are dozens of examples shown there with processing parameters and particle size distribution SEM images. If you're willing to process something new, exciting new alloy that is no existing in pulverized form right now, give us a call. We're always happy to try something new, especially when we're working with researchers progressing powder metallurgy and additive manufacturing across the world. Thank you so very much, and see you in the next episode.